What's up, guys? So here's a little bit different way of showcasing this stuff. I figured to take the time and actually make this a little bit easier to watch. So this is my basic setup for the office. Powerful desktop, does everything. Comfortable desk, 2 monitors, this is like, imagine I have a tune file here and I want to review vlogs. And I want to continue watching the car, or maybe we have the dyno on another monitor, or maybe I'm comparing 2 data files with 2 tune files, right? So just a little bit of versatility. That's not the point of this video. What is, though, is Shane Tecklenburg, Shane T, you guys know him, Mr. Motec himself, thankfully, finally put out a video on CDI. He's been doing a lot of really good spark coil testing, both through his test bench and, of course, when you're seeing 2, 3, 4,000 horsepower cars, obviously there's something that causes those vehicles to work so well and effectively. It's the love, the energy, and the packaging is put together for those things. So, right behind me on the monitor, which you guys won't be able to see very well, is a really good post called 7-Eleven, not just for big gulps. It's on RX7 Club. This is mainly with Howard Coleman. There's like RX8 world record guy, myself, and there's probably 5 or 6 others in here that are pretty well, I would say, pretty well stated the way they go through this stuff. And the reason why I'm bringing up this page and Shane T is in correlation to where on a rotary engine package, what happens on a rotary engine is that we are constantly under a non-cooled position for spark plugs. And the reason why I really like CDI and why I can notice it removing heat from the system, you would think, okay, CDI at 400 millijoules, 750 millijoules, all this stuff should be running hotter than a 115 millijoule smart inductance coil. Well, here's the thing. When a smart coil is operating, its spark energy is going to last for a long duration. I've done, actually on this thing, I have a spreadsheet that I made that will help any one of you. I have a whole other video on this, by the way. If you look at my channel and you look up smart coils, you're going to see probably 3 or 4 videos on it. But what ends up happening is, since the period of ignition event is half of that of a reciprocating engine on a rotary, you run out of dwell time to charge that coil up into its saturation point, in most cases around 9 milliseconds. Since we can't get anywhere near that 9 milliseconds, you're never getting 115 millijoules of energy. At redline, you would have a total of around 6.66 milliseconds repeated, in which you cannot use 100% of that duty cycle to have spark energy, and then it's going to overlap in the next combustion event if it's going for 3.2 milliseconds of duration. So we have a total time of 6.66 milliseconds, and that means that we can only charge that coil really somewhere around 3.8 milliseconds at 9,000 RPM to not overlap into the next combustion event. And what does that really do on a mechanical standpoint? Think about that for a second. That means you are constantly pumping energy into the spark plugs, heating them up. Hot, hot, hot. Well, this thread here, Howard Coleman, great guy. Need to go see him at SEMA again. We always hang out at the Borg Warner booth. He is talking about what he calls the spark plug mountain. What ends up happening is the rotor housing that is holding the spark plug gets a raised region from thermal expansion. And as the apex seal comes down and sweeps that, it'll skip the apex seal, will push out at that region that's now been thermally expanded. And so what I am bringing together with this whole CDI package that I continue pushing more and more cars towards is, instead of that coil being almost indefinitely on and constantly heating this up, when you run a CDI system, it's only giving the spark energy, which is going to be far more immense in power, for a very short period of time, which means you're not heating the system for a long period of time. So what does that do? Well, you see it in any sort of, I would say, misfire knock condition. You see it in thermals, which is the weirdest thing to think about, but your coolant system, because coolant passages go right along the spark plug, you see it there. It's a weird thing. So the car runs colder. You can get away with more RPM, more timing, and a smart coil that I was saying before at 9,000 RPM at 3.8 milliseconds. I can pull it up here actually, and I will. This might be a while. It's page number 6. It's a post that I made. The smart coil is only going to be producing somewhere in the realm of 40 millijoules of energy for 3.2 milliseconds at 9,000 RPM. I'll just skip this. By comparison, you can have a CDI on high mode pushing out 750 millijoules of energy for 0.2 milliseconds, so 200 microseconds. And that's going to produce way less heat into that region, but give you a much stronger kernel of spark energy to blast through higher boost applications. So this whole thread is a lot of our discussion about surface spark plug, or surface gap spark plug, which to me is incredible. I talk about the depth being the ideal depth somewhere at 21.5 millimeters. It is especially important for trailing plugs to have surface gap. There's a lot to that, but I put it in here on this post. But the bottom line is that CDI is not only gaining us 40 millijoules versus 750 millijoules at the same RPM, but because of that energy, it now has the spark event as a sharper, more precise thing. So let's say that I'm commanding on an ECU to fire the ignition at 13 degrees advance from top dead center. Okay, 13 degrees advance, cool. It starts the spark, and it starts it for 3.2 milliseconds. Well, what does that do? Well, it could be hitting at 13 degrees. It could be hitting at 14, 15, 16, 17 degrees. I'm sorry, that would be going the other way. 13, 12, 11, 10, 9, 8. Because the engine's still advancing, or in this case, it's still moving, I should say. And that ignition timing is going to be less precise on a long spark duration engine, or long spark duration coil. And by putting CDI, you're starting the kernel of that ignition, the very start of that flame front, at a very precise time. It's going to fire off. It doesn't take that long duration to do it. Once that's started, it'll go and homogenize throughout the whole AFR, or the whole air and fuel mixture, excuse me. So, trying not to get too far ahead of myself, but that's the other benefit of CDI is now, when you set your timing and you're optimizing the find MBT, you are way more precise on what you're hitting. So I can now fine tune the true MBT of an engine at a much more precise region than if I were to run an inductance coil. So that's a benefit. The temperature's benefit. There's only two drawbacks, really. I'm going to say that there are two drawbacks. The initial expense, right? Significantly higher. You're talking, so in a standard ignition coil configuration, you're talking a factor of 7 times more expensive to go CDI versus inductance coil. So that's a big drawback. Besides that, you could have an issue where you're picking up electromagnetic interference. And I've talked about this before, and I think it's a very important thing to think about, is when you create your whole start point ground, you've got everything else working off of that. It may benefit you to have, on a CDI especially, have shielded M27500/32 wire to run that whole coil system, everything. So you're running shielded, ground shielded wiring to the ignition coils to where it's not picking up as much electromagnetic interference. The CDI also requires that you have to have a very minimal gap. So for instance, the S31A that I love to run for naturally aspirated engines, which I've sent off to Adam LZ to help with his split timing and optimizing an NA application, that gap is somewhere around, I want to say 31 thousandths of an inch. That's too large for CDI. CDI will have to have a resistorless or a non-resistor spark plug. And I have, a whole bunch of the spark plugs here that I could show you that are ideal for CDI. So those may be expensive, those may be cheap. It depends on how you're operating. There are so many benefits though when it comes to, hey, I can grab a set of Hemi spark plugs that are 19 millimeter depth and they protrude out with this very thick ground strap that cannot break. And those things are going to be little torches in a rotary essentially, because when the ground strap gets really, really thin and it's pumping a lot of heat into a system like an inductance coil will do, you'll see it glowing and it's going to melt off the, I think it's cadmium that's on the, especially NGK plugs have these, and you'll see how warm that plug is getting. With CDI, again, you're not pouring the heat in all the time. And so the benefit is your plug life is actually going to be longer if you're using it properly and it's not picking up any misfires. There was initially on the, I want to say FuelTech Gen 1 CDI box, an issue where it was picking up a lot of inductance noise. And what that does is it's going to misfire that CDI box, and it's actually going to burn up a set of spark plugs really, really fast. Something to take note of. So shielding's important, grounding's important. Spark plug wires, if you can grab something that is a spiral wound, like Dragonfire or something to that effect, you'll be really well off. And then getting the right plug for the job. The CDI manufacturers will go through this whole list of what works best for their product. The M&W and the FuelTech coil themselves, the little 3-wire dumb coil for CDI, those are identical. There is a polarity difference between each company, so take note of that. You can run a dyno run, boom, do it exactly like it is, keep the same power level, reverse polarity, try it again. You're going to see if you've got different spark energy. It's probably going to be lower because you probably got one brand and followed the same brand, but in the scenario you bought M&W coils and you put them on Fuel Tech or CDI or Fuel Tech and went on to M&W and you did some flip-flopping, it might be out. That's where you want to check out Shane T's video. It's freaking amazing. You guys are going to love it. Essentially, he was finding crazy high millijoule output and a colder overall operation for the same spark event. So, very impressive what you can do with CDI. And because you're able to get so much power in so quickly, it cuts through all the boost. No more chance of misfire. It's like the equivalence of having E85, which is not knock limited, on a car that was previously very knock limited. It's just wonderful. So you're moving everything in the right direction, and I hope that helps, and I hope that gives us better insight to really pushing limitations for these things. In this thing, I talk about good thresholds as far as like wheel horsepower for each spark plug, the gap, which coil systems can handle this, which coil systems are a little bit better than others. I went through the whole thing. Howard does too. And essentially now they're trying to turn down R6601s to create the proper depth of the 21.5 millimeters that we need, because it was originally a 19 millimeter depth plug. So they've got a process to do that. Pretty much just being put up in a lathe, run through one at a time, cut down, adapted, and they're dialed. And this plug has been the golden child. So I'm happy with it. One other thing, what else did we go through? Oh, heat ranges. Rotary's always wanting the coldest heat range possible. The reason why that has become such a common theme to be talked about is simply because of what I was saying, the inductance coil charging and charging and charging, taking all that time and pouring out a over 3 millisecond spark duration when you have very short periods between the engine. So I think I'll leave it at that. CDI is always the better option. It's more expensive. It's where you want to go when you want to go over 8,500 RPM, over 25 pounds boost. That's your answer. Makes things reliable. That's all I can say. So let me know what you guys think about this video, the setup, the camera, the arrangement here. I think what I'm going to end up doing is I'm going to probably talk to Claudio about opening up our paid series more. I have it on Tuning Technology right now. If you go to tuningtechnology.net, we have, I believe, 12 or 13 videos for introduction to EFI. And it's a package we're selling. The cost is, I think it's like $100 or $150, whatever it is. Claudio and I are splitting it directly. He's hosting it, goes to a YouTube link. It opens up and you'll see, all these videos that are going to be pretty long. I think they're about 45 minutes each. And they'll go through the stuff that you guys ask questions about all the time. We were extremely thorough on how we approach this, and I want you to see a different tuner's perspective. So we will have kind of our little inputs, but then we have the same path on what we want for results. So I really hope that helps. If you guys don't like those, let me know. If you like this style format where I'm just off the cuff and going for it, let me know. If you hate all this, let me know. I really don't care. So I hope this helps some of you out. That's the goal. If it doesn't, sorry, go elsewhere. That's all I can say. All right, cheers, y'all.